In this video, we are going to talk about a pretty controversial topic in C-level language, the null pointer. So if you look that up on the internet, you might see some discussions about this topic and about the value. But you don't have to look that up because I will tell you the problems with this value and our solution, of course. Okay, so the first thing we want to talk about is what do we want to do? So you remember when we have when we have variables and we didn't initialize them, local variables, they will get any value assigned to them. So this is pretty random, and we are not sure what kind of value will be inside of A at the moment of execution now. So we have the same problems with pointers. So we have, first of all, we have local pointers and global pointers, as well as local variables and global variables. We already talked about that topic. And the good news is they behave the same. So a local pointer will have a random address assigned to it, and a global pointer will have the zero address or the null address assigned to it by default. So that is the first good news. And the second one is before we used to, let me call that pointer, before we used to initialize variables with the zero value. And you can also do that with pointers. But sometimes you will see this value. This is a special value which has a numeric value of 0. In C it's sometimes a little bit different, but if you are interested in the correct definition of the null constant, you can look that up. That's perfectly fine, but we are already satisfied with the definition of 0, and I tell you why. First of all, we can go ahead and say, okay, please give me the numeric value of null, and this will, I forgot this one, and this will output 0, just 0. So let me show that to you first. So you see we have the numeric value of 0, which is not very surprising. Okay, so we keep this thing in mind now because I want to show you, I will remove that. The first thing I want to show you is the address of our pointer now. Memory address of a PTR is and the format string for memory address of a pointer is %p, and of course we can get the address this way. If you omit the null value, you will get a random address. If you initialize the pointer with the null value, you will get the null address, which we will see now is just 0, 0, 0, 0, and so on. Okay, so that's pretty cool, and that's also one reason why we want to believe this is just null, because here the same thing will happen. Everything is fine. The second thing is a reason why we do this in the first place. Why we want to initialize a pointer with null value, either numeric or this special null value, because we can go ahead and say, okay, I check this value inside of an if condition, and now we can check if our pointer is initialized with a, let me call that a good value, because of course if we don't initialize that pointer at all, we will get some silly value. We don't know what's inside of there. So if we have a good value or an intended value, we can check that if we have the null pointer before. So now you can see our pointer is not initialized because it's on the null address, and if we have a random address inside of it, of course it is initialized with some random value. We don't know which value this is, but the reason why we want to initialize it with the null value is we can check if we have a plausible value inside of here, and if that is the case, we print out some value or we calculate some value. We can work with our pointer. If we never initialize that pointer, we will calculate or output or whatever we are going to do here a random value, just like with local variables, and that is not something we want to do. So one more thing we want to talk about is why this is working. This we learned about the if structure, and I told you that inside of our brackets here we have a condition, and this condition can either be true or false. So we assume that the null value is false, which is correct. Because our pointer, if you remember, our null pointer didn't print anything here, so it must be false. So this has the value null, and the value null ultimately is just a 0. So we have learned that 0 is just equal to false for C-level language, and this is correct in every case. And usually you could say, okay, this is binary, so that means that 1 must be true, and that is also correct. 1 is equal to true in C-level language. You can see I have an output here, and if I set this to 0, I will have no output here at all. So what this means, if we initialize our pointer with null value, it's just a 0, and this means we can check that with a condition because a 0 is always false. And that is a good news for us. But I have still have one mistake here, because this is not entirely true. Any value other than 0 will be true. So if x is a variable and x has any value other than 0, it will be true. And this means every random memory address, every other memory address will be true. The 0 memory address, of course, is reserved and can't be achieved by a random memory address. We can't assign a variable that has memory address of 0. So, in conclusion, what you need to learn from this video is the following. We have a special type, null, and this constant stands for 0 if you just think about it in a very easy way. And if we assign the null value to a pointer, it will be set to the address of 0, to the 0 memory address. And we can check this address to be true or false. That means if later we will initialize a value to our pointer, we can check if that value already has been assigned. If yes, we can do something. If no, we wait for that value to be assigned ultimately. Okay, so now one more thing about the null expression. In C, we are going to work with the null expression for pointers. That has two reasons. One reason is just because it looks good. And the other reason is because if our code will get bigger and bigger, we can just search for the null value and we will find our pointers. If we just search for 0, we might find other values too. So this has just practical reasons in C. If you like it better, you can work with the 0 value here. That is no problem at all. Null in C is just a macro which assigns some kind of the value 0 to that expression here. In C++, we will use another construct for this because the null constant is causing problems in C++, and we are going to work with C++ 11, which means there is another construct for that null type. In other programming languages like C#, we are going to see C# 2. Null is also a special value, and that is an object value. So it will be different in every programming language that you will see. And we are going to talk about the null value over and over again. It really depends on the language you are going to use. So keep in mind that in C, this is true. In C++, you shouldn't do this. And you can look it up on the internet, you can check the definitions. You will see this topic is highly controversial, and we are just keeping it simple. We are trying to keep it simple here. Okay, in the next video we are going to learn some arithmetic operations on pointers, which is a kind of very interesting topic, and we will go back to our talk about arrays. So we will build on our knowledge again, and then we will have some exercise, and then we are going to learn complex structures. Okay, see you in the next video. Bye.